Okay, good evening, everyone. It is 8:10. We've got another 20 minutes before we get started with tonight's conversation on turning your house into an escape room. I'll be giving a presentation that I've called The Hacker's Apprentice, which is the theme and the name of the escape room that I've got in my house. Okay, but between now and then, I thought we would have a little bit of fun, play a little game while you're sitting there. This game is, can you figure out which song I've written in Python? So you've all got your chat windows open, or so you've got a chat window available to you in the webinar. So in your GoToMeeting, everybody pull up your chat. And let's see, Carol, do I have to do everything so that people can send to everyone in chat, or send to the organizers? I guess you'll be able to send to the organizers in chat, right?
I think it would be best if they responded to you in the questions window.
In the questions window? Okay,
Yes.
So in the questions window, you can send me your answers to the following questions. I'm going to bring up a song that's been written in the Python programming language, and you're going to have to figure out what the song is. All right, to give you an example of what I mean, let's go with an easy one first. Okay, now each of these slides is timed. So this is in a Python prompt. We've typed that command, and well, that can be read as a song. Morgan Whaley. Good evening, Morgan gets it. All right, Philip gets it. Well done, well done. And if you know what that song is, then type that into the enter. Yeah, ooh, I almost said it, into the question window. If you can't find your question window, just let us know by typing a question into your question window. Okay. All right, so you get the idea.
A little joke there?
Yeah, I wasn't quite sure where. It started coming out, and I wasn't quite sure where to go with it. Right.
I liked it. I liked it.
Yeah. All right. So well done, Morgan, Philip, and Jew. Well done. All right. So you get the idea. Let's try another one. Okay. All right. That was Metallica's "Enter the Sandman." The next song. Can you identify the following song written in Python? Do 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 do. Very good job, Morgan. Do 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 do. Morgan, quick to the keyboard on the songs. Well done, Patrick. That's correct. Correct. All right. Very well done. I need a scoreboard is what I need. We need to figure out the score. This needs to be a Net Wars tournament challenge. Okay. All right. So very good. You got the idea now. Okay. Here's another one. This one's not too difficult. So that one was, in fact, "Forever Young" by Rod Stewart. All right. Here's another one. Not too hard. We're just warming up now. What is this song written in Python? Morgan got it. Is it Joa? I know I'm mispronouncing your name. I apologize. It's close to that. Johnny, got it. It's close to that. You're close. This is by Journey. The song is "Don't Stop Believing." Don't Stop Believing. Excellent job. Excellent job. All right, let's do another one here. This one's a little more difficult. We're going to up the ante a little bit. What is this song written in Python? Can anyone get it without a hint? See some people typing. Very good. Very good, Johnny. Song, okay, here comes the hint. Looks like Johnny's the only one gonna get it without the hint. By Weezer. Yep, by Weezer. It is indeed an excellent song, Johnny. I concur. It's by Weezer. It's I Got My Hash Pipe. Dum, 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 dum. All right. I Got My Hash Pipe by Weezer. I don't see any boos and hisses in the question mark, so I'm guessing that everybody can see where that's the correct answer. All right. Thanks, Alyssa. All right. Weezer, I Got My Hash Pipe. All right. How about the following song in Python? This one is, I got this one off of Twitter by Infogroke. Thank you, Infogroke, for this one. Can anyone get it without the hint? If you're not familiar with Python, the random function chooses a floating point number between 0 and 1. So, say there's a 50-50 chance of what's going on here. No, it's not it, Johnny. Here's a hint. I don't know when, this was during the Olympics, right? Everybody had to do a version of them singing this song, including lots of Olympic swim teams and everything else. Very popular song, pop music. If I give you the name of the artist, there you go. Patrick got it. Patrick got it. It is Carly Rae Jepsen. Call Me Maybe. There's a 50% chance that it is going to call the me function. So it's call me maybe, 50% chance. All right. All right, they're getting a little harder. They're getting a little harder. How about this one? Can anyone get it without the hint? Yes, very good. Johnny got it. Phil got it. Come on, Morgan, you should know this one. I know how old you are, Morgan. The song is by Wham. Correct, Patrick. And it is Last Christmas. So the date time function, right? The date time function is what we'll create a date object in Python. And here we set the year equal to now.year minus 1. And then the month to December, the date is the 25th. So this is going to come up with Last Christmas. All right, so this one's really hard. So this one's Pop 2010. I'm going to give you the category in the year because it's a hard one. I've actually only had one person get this when I've done this before. Okay, but I got a good feeling about Johnny on this one. Let's see. 2010 is not the oldies. All right, 2010 pop music. The artist is Rihanna. The artist is Rihanna. Johnny got it. The Only Girl in the World by Rihanna. This is what's called list comprehension. We're building a list of I for I in world, and if the gender is equal to female, it's going to build a list of all of the eyes in the world whose gender is female. It's going to look at the length of that. And we can see that the length of that, when compared to the number 1, is true. So this is the only girl in the world. All right, how much time do I got? I got 10 more minutes before we start up. Here's another one. Can you identify the following song written in Python? Oh. Google is not cheating, Johnny. You are perfectly legit in Googling stuff. Jeremy got it correct. Excellent job, Jeremy. And Johnny got it correct. Okay. What's happening here? Well, we're doing a DIR on the object today. Now, because we do a DIR, it gives it back a list of all the attributes. We can see the first attribute is that it's an object, which means it's based upon a class. And if we look inside of that class, we see that Jeremy spoke is in class today. So Jeremy spoke in class today. This one is Pearl Jam, Jeremy. Okay, excellent job. Well done. All right, so this one, oh, I'm just going to skip that one because I hate it. All right, how about this one? This is such a good one. Such a good song. We import time. We import random. We have a list of destinations, among them Staten Island, Manhattan, Brooklyn, Queens. And then while true, we're going to choose Alyssa. Excellent job, Alyssa. First to the punch with that one. We're going to choose a random destination. And if it starts with a character 66, what is character 66? If it starts with a character 66, then we call the sleep function. Otherwise, we do nothing. What do we got? Alyssa is going to carry the torch for all of you on this one. There you go, Patrick. Well done, Russell. It is No Sleep Till Brooklyn. It's going to sit there in that while loop forever, just going around until the random destination is chosen that starts with the letter B. When the random destination is chosen that starts with the letter B, it will call the sleep function. No Sleep Till Brooklyn. All right. This one is classic rock. Classic rock. So I think 1970s, 1970s, classic rock. Here we're using the threading module that's available to us in Python. Threading.enumerate generates a list of all of the threads that are currently running. And then we're going to look at the name of each of those threads. And if the name of the thread is equal to music, and that thread is not currently running, then we are going to print. Very good, Patrick. We're going to print today's day. This one is the day the music died. This is Don McLean's American Pie, the day the music died. All right, 5 more minutes. How about this song? We import the calendar function. We call calendar.dayname, passing it in the number 5. We then turn that into a list, and we append the word night to it. Excellent job, Johnny. Excellent job. Most people would say day 5, that's going to be Friday night, but in fact, in Python, it is Saturday night. Saturday night. So this one could be the Bay City Rollers Saturday night, or it could be Wigfield Saturday night, or it could be Suede Saturday night, or it could be Khalid Saturday night. Whatever Saturday night makes you happy is why we are here. So that's that one. How about this one? Soft rock 1975. Okay, soft rock 1975. We have a function called your lover. And forever, we're going to choose a random integer between 0 and 99. If it is evenly divisible by 2, then we return, leaving the function. What is this? 1972. Ah, very good, Micah. Micah Hoffman got it. Excellent job. Any others? Any others? It is not part-time lover. It is not easy lover. There, so it's choosing a number between 0 and 99, but then it's eliminating it down to just the even numbers, which means there are exactly 50 ways that this could return from the function, leaving function your lover. There are 50 ways to leave your lover. Yes, okay. I'm gonna skip this one because we don't have time. Okay, how about this one? Pop Rock 1980. Now let's skip this one. I'm coming up on my time. How about this one? Pop 1989. I don't even remember what this one is. Well, let's do this one. Let's do this one. All right, Pop Music 1989. Oh, I know what this one is. Not my favorite. I don't like this one that much, but it's a decent challenge. So we choose, or we call the date time function. I have an obvious typo in there, date t time, but that should be the datetime.datetime function. We record the current time, and then we attempt to subtract 1,000 from the current time. Then, if the current time is less than the variable we recorded in current, and we can find a way, then we print, maybe you'll stay. Yes, this one is 1980s. This is Cher. If I could turn back time, if I could find a way. All right, enough of that. All right, how about this one? Some hip hop, pop hip hop 2002, pop hip hop. Oh, I got to show you the song. There you go. Oh, I love this one. I love this one. Hip hop 2002. Can barely contain myself dancing to the song in my head right now, waiting to scream the answer. It is not Baby Got Back. Oh, Patrick. Excellent job, Patrick. It is not Wild Thing. What do we got? What do we got? No, not I Do My Thing. This one, for this one, you got to know that square bracket colon 1 reverses the string. So to do this, what I had to do is I had to put my thing down, flip it, and reverse it. Missy Elliott, work it. Missy Elliott, work it. Yes, I can hear the boos and the hisses coming across the mic. I'm so glad that there's no microphones on those other sides. Let's see, we got. Oh, it is time to start. This will be the last one. Last one. Time to get started. Here we go. Last one, and then we're going to jump on tonight's content. If you've just joined us, we're just playing a game. This is the pre-show banter. It was all recorded, so you can go back and watch it if you are interested in what we've been doing here. Okay. Hey, Jesse. All right, so this one.
While they're taking a guess here, I just want to be sure that when you start officially, if you could announce that there's an evaluation for this that I'll be putting in the chat window for all to see. Thanks.
Excellent. There's an evaluation for the pre-show or for the actual show?
I think it's for the actual show, but we can throw the pre-show in there too.
Okay. All right. Excellent. Okay. Excellent. So we've got a couple that got this. Philip got it. Micah got it. Anybody else? And I'll give you a hint. This is just the perfect way to end some pre-show banter is with this song. Perfect way to end some pre-show banter. Mike is not disqualified. All right, no, it's not everybody but you. It is, we've got this function called give. It's going to make a random choice of all of the possible letters. And if the letter is not a U, it will return the uppercase version of it. But if it is a U, it will return none. And then forever, we're going to call this give function, but forever, that give function is, well, it is unfortunately never going to give you up. For the last 30 minutes, you have been experiencing SANS' longest running Rickroll. All right, there you go. So welcome everyone to tonight's presentation of the Hacker's Apprentice. Before I get started, in the chat room, help me out here, Carol. Was it in the chat? Was it in the questions?
Yep, chat window, the chat window.
Thank you. In the chat, you will see a tiny URL. That is the evaluation for tonight's presentation on the Hacker's Apprentice. A little bit later, I'll also be putting another URL into that chat window for you to watch a video of the escape room in my house being played. So be sure to find your chat window, be able to find that link. So good evening and welcome to my presentation on the Hacker's Apprentice. My name is Mark Baggett. I am a Senior SANS Instructor. I'm the course author for SANS SEC 573, Automating Information Security with Python. I'm one of SANS GSEs. I've got some commercial experience where I was a Chief Information Security Officer, and now I'm doing a lot of work for the Department of Defense over the last 10 years or so. Other things interesting about me, so I'm very happy, proud of the fact that my name appears in the source code for Metasploit 7 times, even though I've written 0 modules. And I'm not necessarily just proud of me, but what makes me so excited about that is just the fact that I've written no modules, but the information security community as a whole has saw fit to actually give me credit for some research that I've done, for some TTPs tools that I came up with, and actually put my name in the source code for those TTPs. So when other people develop tools, they were willing to give me credit. And I can't imagine another industry where people are that kind and able to do that. I can see that. So so thank you to the community. So tonight I'm going to talk to you about the escape room that I built in my house, and the name of that, well, the theme for that escape room is the Hacker's Apprentice, right? And so let me just tell you a little bit about why I did this thing. It took me about 5 hours to originally put together this escape room, and I've had just a ton of fun with it. Lots of people have come by my house to do this. I've had teams of folks from the Army. They've reached out to me and said, hey, can we come by and do the escape room? And so there were a couple of times that we've had just teams of people coming through and doing the escape room. So this escape room has just been the source of lots of fun in the house. I've had coworkers when we have SANS instructors come into town. I've had many of the different SANS instructors have been come over and done the escape room. Coworkers and, well, complete strangers have all been in my house to do this escape room. Why I did it is because, well, Ed SCOTUS is the root of all evil, right? I went to DerbyCon in 2016 and I sat there and I watched as Ed SCOTUS talks about how he's turned his office into this amazing Jarvis-enabled just maze of various IoT devices, and he's tied them all together with all these different Python scripts. And the first time I saw it, I thought, yeah, I I should really be looking into that. He's got a lot of cool stuff he's doing with Python. I should look into that. And then I blew it off. And then the next year I come back in 2017 and Ed Scotus gives this presentation on further adventures in smart home automation. Honey, please don't burn down your office. Yes, and this presentation, it was just amazing. Ed talks about how he's tied in these different weird contraptions that he's got in his house into automated systems, and I thought, well, that's it. I've got to go back and I've got to learn how to do these types of things in my own house. So after DerbyCon 2017, I come home, I start reading about IoT, Python modules, and I come across this Python module called Home Assistant. And Home Assistant is amazing, right? SANS, it's a free open source product, which means we can talk all about it all day and just tell you how great it is. But even if it was a commercial product, it is that good. The quality of the product, the constant updates, the level of effort that's being put in there, it is just an amazing open source product that can do all kinds of things. And I'm going to show you all the features that we have in Home Assistant. Well, not all of them, but many of the different things we can do with it and how you can use Home Assistant to do some cool things at home. So I'm reading all about Home Assistant. I'm like, oh, this is amazing. This is going to make doing home automation so easy, and I want to do it right now. And so I open up my computer and I start working on things. And then my wife comes up to me, and this is on a Wednesday, and she says, hey, I need you to pick out a game or come up with something for us to do on Friday night, because, well, we got a bunch of people from church coming over, and these are not going to be highly technical people. They're not going to be nerds, right? So I'm like, I'm torn. I really want to do Home Assistant, but I've got to come up with a game or some activity for us to do. Escape room, right? So I decided right then I was going to try and build this escape room in my house. I needed to have, I had about 48 hours, and I needed to come up with a set of puzzles and then figure out the automation and do this thing at a level that was appropriate for the audience that I was having coming over. So that was the problem. The solution was Python plus Internet of Things plus Home Assistant. It turned out to be pretty fun. And like I said, we've had many people do it since then. So let's talk about Home Assistant. Just an overview really quickly of the architecture that you have inside of Home Assistant. Really the key to Home Assistant, the thing that makes everything work, is this event bus. Right? This event bus that you have, it ties everything together. All of the devices you have in your house, the light switches, the thermostats, the software functions that you yourself write, they all tie into this event bus, and they all listen for messages that are being transmitted by the other devices. So when a light is turned off in your house, well, it sends a message to the event bus. And the event bus then rebroadcasts that to every other device, and it then knows that the light switch has been turned off. And so then you can tie together these various events, right? When you see that the light switch has been turned off, then I want to take these actions and cause this other device to turn on or change its state. And then that device sends out a message once that's done, and that triggers other events and things like that. You also can define your own timers. So I can have events or timer events that will just put a message onto the event bus and say, hey, it's this time, and then I can have things trigger based upon that. Among the different types of components, you've got your traditional things like lights and switches that you can have on web pages and things like that. But you also have device trackers and other things that you can have in your system. We're going to talk about these things in some detail in just a minute. Okay. All right, so that's a basic overview of Home Assistant. Now, the best part of Home Assistant is even if you're not a programmer, if you have no programming background whatsoever, you can still just turn this thing on and let it find devices on your network. And you're going to find that it automatically configures things and lets you control devices in your house without doing much configuration. They work really hard at giving this thing a web interface that non-programmers can install this piece of software and then begin controlling the devices in your house. Now, there were things that it found in my house that, well, I expected it to find, things like Alexa and Google and Siri. I would have expected any kind of home automation to talk with those type of devices. My Apple TV any kind of IP-enabled light bulbs, thermostats, cameras, or IP-enabled locks on your doors, things like that. Those are all things I expected that it would find, but it went beyond that, and it discovered things that I have on my network that I knew were there, and obviously I knew they were running on my network, but I really didn't think that this home automation system would have any interest in discovering these devices. Things like my networking gear. It found via the plug-and-play services that were on my networking gear that the networking gear was present. I'm like, why would an IoT device care about my Wi-Fi router? Well, that's one of the really nice things about this. With the Wi-Fi router, it can query the CAN tables on my devices, and based upon that, know, well, who's connected to my Wi-Fi. When I have someone connect to my Wi-Fi that's never connected to my Wi-Fi before, I can have that trigger an event. I can have my lights blinking in my house, letting me know that some unknown person has connected to my wireless network. Or when I connect to my Wi-Fi, then it can trigger an event. So this is how it knows that I come home. So when I come home, I come into range of the wireless with my phone. My phone connects to the Wi-Fi. That MAC address appears in the CAN table, and then automations can occur. These kind of things are all reflected in, well, a pre-built web interface. So the web interface you see here on this iPhone in the corner is pre-built, canned, out of the box, right? So all of the indications here, you can see this is not me, this is a sample that I pulled off their web page, but here you can see who's home on this device. Right? You can see different temperatures that are on there and so forth. Here on this, you also see examples of switches and things like that you can configure. Other things it found iTunes library, so you could have it automatically play songs. It found all of the televisions that I have in my house, and it can Chromecast to those devices, Apple AirPlay to devices, right? So it can, based upon events that happen, stream media automatically to the different devices in the house. It found my Blu-ray players and my DVD players, and ready for this? My Blu-ray players and my DVD players have no networking whatsoever. They are not on the wireless network, they don't have Ethernet cables, and yet I can control my DVD and Blu-ray players. And you would say to me, but Mark, how does that happen? Is it magic? Well, what happens is it finds my Harmony remote control. So Harmony is a remote control by Logitech, which is a wireless device. And that wireless device then communicates over infrared to the various devices. And well, the Harmony remote is IP enabled. So I can control televisions, DVD players, and other devices that aren't even on my network via Home Assistant. So when I come home, automatically turn on the Blu-ray player. These all types of things are all possible. It found my sleep number beds, and I can trigger automations based upon, well, the settings in my sleep number beds, whether or not it sees that I'm lying in bed or not. So it knows when we're there. It also found my security systems, and I can disable or enable my alarm with the security system. And I'm a security professional. If you're like me and you're, wait a minute, so someone over your wireless network can disable your security system? Does that really sound like a good idea? Well, the great thing about Home Assistant it is an open source project. So all of the code you have in there, you can go in and you can comment out the sections you don't like. You can remove the sections of code that you don't like. So if you don't want the security system to be able to turn off the security system, it's as easy as going in and disabling that functionality in the code. If you say, oh, Mark, I don't know how to code in Python. Well, two answers to that. One is, I've got a really nice course I'll tell you about when we get to the end of this that can help you to do some Python coding. And the other thing is, don't worry about it. My personal experience has been that people who don't know how to code are the best ones out there when it comes to disabling functional code inside of programs. So you can do this. Don't worry about that. Home Assistant has hundreds of integrations. Rather than showing these slides, let's look at this. I got a home internet connection. So this is Home Assistant's website. And if I come out here to integrations, right? So it's got 1,566 different types of devices that it integrates in with. And here you can see the categories of things. So it can tie into various climate control systems. It can tie into various cars, so it'll know when your car is up for service, right? Or your car has come within range of your house, depending upon how you got these things configured. We can have different, let's see, presence detection, right? So here's some of the presence detection, different ways that it knows where you are, and have devices or functionality that scripts that run based upon your presence, right? If your car is in the driveway, it can tie into like the Apple's where's my device, and know whether where you are based upon that. You can have scripts that run when you come home. Ties into various IP cameras. You can have things based upon cameras. It'll also have different scripts that can tie into things like the Postal Service. Here, health. Right, here's health. We can click on health, and here you can see that we've got all kinds of things in health, including COVID virus, COVID-19 information. So based upon data changing in John Hopkins database, I can configure automations, right? So when the escalation rate reaches a certain amount, then I can go into an automation such as, oh, I don't know, let's see. I can go into transportation, right? And I can then use, I can order myself a lift, use Google Maps to figure out how long it's going to take me to get to my secret bunker, and then order Lyft. Then of course I'd have to get rid of the Lyft driver. I'm not quite sure how to, I have to think this one through fully before we get, but you get the idea of the types. You can see the integrations that we have here are extensive. Lots of things we can do with these integrations, okay? And many of these things that I've talked about, the integrations all come with these nice web components that really, via no code at all, you just turn this thing on, let it discover your devices, and then you can, well, start seeing what your settings are. You can click buttons to control different devices in your house. So it's a very nice and easy system to use. It also has extensive logging of every event, right? So down here at the bottom, you see presence of different people in my house as to whether or not they're home or not home, based upon, well, the presence of their cell phone. Is their cell phone in the building? Is their cell phone not in the building? Home Assistant, one of the reasons that they came up with this idea was really their focus is on security. Home Assistant, if you read the architecture design decisions, they really dislike the idea of Alexa and your thermostats or your different IoT devices you have inside of your house, all having to go out to all of these outside cloud providers, right? So the idea of Home Assistant is, rather than having to open up all of these things in my firewall, what I want to have happen is every device inside my network talk to Home Assistant. And then Home Assistant could talk directly to those providers. That's one way you could do it. Or another way you could do it, and perhaps a much more secure way to do it, would be to have this cloud service, right? They have a paid cloud service where you can have your internal Home Assistant talk to their cloud service, and then you only have one port enabled on your firewall from your Home Assistant to the external cloud. But you don't have to use their cloud. If you want to host this yourselves, all the software for that cloud service is free and open source. So you could stand up your own Amazon instance that has open access to all those different devices, and then lock down your internal Home Assistant so that it only talks to you in the cloud. So they've really put some thought into the architecture and design of these things. It also supports custom components. So if you've got some weird devices in your house that aren't in that 1,500 different devices that it has out of the box support for, you can add your own. For example, in my house, when I bought the house, it came with these intercom systems where you could communicate between different rooms. You could turn on speakers in rooms and play music throughout the house. And it was by a company named Legrand. It was Legrand on Q. And there's no support for Legrand on Q inside of Home Assistant. But it's open source software, and they provide you with templates so you can create your own. So I took an open source template that they provided, and I created my own support for Legrand on Q. And you can see here I did a word count on it, and it turns out to be about 200 lines of code. I'd say of those 200 lines of code that we have in this program, maybe 50 of them are written specifically to work with Legrand, and the rest of them are all templatized, right? I saw the comment out there that it sounds a lot like if, this, then that, or ITTT. And a lot of the components that it has do behave very similar to if, then, this, then that, but it is all happening inside of your house instead of outside in the cloud, right? And if this, then that is actually one of the components. So all of the capabilities you have inside of if this, then that can also be integrated in with the other automations you have in your house. All right, so let's start talking about the escape game and what I had to do. So another way you can do this, other than configuring it through the web, you can also configure it using YAML. All the configuration is done with YAML. So what you see here on this slide is a YAML file that I have that creates light switch or switches that I've got in the web interface. For example, I've got this object that I created called Automate Lights. The name of it on the web page is Light Automation. And here you can see how that thing appears on the web page. It appears as something called Light Automation. It's got an initial state of being on, and I can define what the icon that I want associated with it is. And so by just creating this YAML file, then all of these switches you see here now appear on the web interface that appears on, well, my devices, my mobile devices that connect to my home automation system, and the web pages inside of my house. Now, these switches by themselves don't do anything other than, well, you click them and it flips it, right? Changes the state on the web page. But really, they're just switches on a web page with no automation behind them yet. But we're about to add some automation. Let me just point out this one here that's called Some Password, right? It's actually changed the name of it just in case any of you ever come to my house. I didn't want to give away the password here. But there's a password that here, we'll come back to that one a little bit later. But you can see that each of these are just switches that I can toggle on a web page. So now I want to put some meat, some action behind these. So without any coding, I can again put actions behind those switches, because one of the features that Home Assistant has is it has what's called the Philips Hue Emulator. So if you've ever experimented with like the Philips Hue light bulbs, you put a device that looks like this on your network, right? And that device controls all of the IoT devices that you have in your network. And Alexa and Siri and all of these other voice-activated control systems, they know how to talk to the Philips Hue box on your network. So I can tell, hey, Alexa, turn on the lights in the kitchen, and it will talk to the Philips Hue hub, and then that will tell the lights to turn off and on. Well, built into Home Assistant is a Philips Hue emulator. So Home Assistant looks like a Philips Hue hub sitting on the network, which means every switch that I have on the web page appears to be a light bulb that's on my network that can be turned off, turned on. And you can also control the brightness of different light bulbs, so you can have different levels you set them to. All of those controls that you would normally have available to turn off and on light bulbs are now that are available through Alexa, Siri, and your other voice-controlled systems through this Home Assistant emulator. So now, with Home Assistant and just my YAML config file, I can say, hey, Alexa, turn on the escape game. And then the button that I have on my web page that's called the escape game will be, my Alexa in the hallway heard me say that and just started the escape game in my house. Oops. All right, so the switch in the web page will just turn from off to on, right? So that's all that happens there, is that by you saying that, it goes to the Philips Home Hue emulator and flips the switch. But still nothing happens. We've just, well, toggled a switch on a web page. So now I can toggle a switch on a web page, which does put an event onto the event bus, right? Now my event bus has something that says, hey, the escape game has turned on. And now I can use that to trigger an automation. You can create automations, again, through the web interface without any coding. What you need is that trigger, that thing that was on the event bus that says, hey, the event bus or the escape game was just turned on. And then you're gonna, based upon that trigger, you're gonna add some conditions, like I only want this action to occur in the following conditions. And then you're gonna add actions, one or more actions, one or more triggers. So it looks like this through the web interface. I know that's all very small, so I'm gonna zoom into these one at a time. So first, let's start with this page here, which is the trigger. The trigger looks something like this. So when there's a state change in a particular device that I have on my network, such as my downstairs thermostat's occupancy. The thermostats in my house know when someone is in the room, right? And it can adjust the temperature in that room accordingly. But I can also tie into those presence detections with my device. So when the downstairs thermostat's occupied or occupancy sensor changes from occupied or from unoccupied to unoccupied, that's the trigger that's going to start this event. I'm also going to add some conditions, right? I'm going to check the state of the device tracker associated with Mark. And I'm going to see, is Mark home? So when the device goes from unoccupied to occupied and Mark is home, and it's between sunrise and sunset, it's before sunset and after sunrise, so I only want this to happen during the daylight hours, then I'm going to call the media service, call a service called the media extractor, play media, and I'm going to tell it to, on my television downstairs, play this YouTube video, which is in an MP4 format. Now, as soon as my occupancy sensor changes, if I'm home and the sun is up, then it's going to look at the state of my television. If the television is turned off, it turns on the television. If the television is set to a channel, it will stop that channel and it'll flip it over to the Chromecast service so that it can begin playing whatever video I've got set here, and that will just begin playing on the service. And this is done with absolutely no coding whatsoever. It's just configured through the web interface. Or I could have it call a service, such as a script. I can have it run a specific script, and this script can be a Python script. So in this case, I've got a Python script called escape welcome that it'll automatically launch on the network. Now, in addition to configuring things through the web interface, you can also configure them through YAML. So this is a YAML configuration of an automation. This is my good night script. Okay? So the good night script, what it'll do is the triggers are based upon the binary sensors in my sleep number beds. It looks to see, are the sensors in my sleep number beds set to on? Then it looks at the conditions of all of my devices, all of the sensors that I have that indicate whether or not people in my family are home. And if we are in bed, my wife and I are in bed, and everyone is home, and it's after 9 o'clock, then it will turn off all of the lights in the house, right? Lights.all turns off all of the lights in the house, and it will turn on the alarm inside of my house. So based upon those sleep number sensors, it knows we're in bed, it knows we're home, automatically turn off the lights and turn on the alarm in the house. Okay. Now that's my good night script. This is my great night script. If my wife and I are in bed and the kids are not home, then we turn on the lights in the bedroom to 50%. And then we have Alexa say, play the romantic playlist in the bedroom. Ha ha ha, the great night script. But don't get too excited about that because it doesn't work. It does not work at all. Well, I mean, functionally it works, but it doesn't have the outcome that I would expect. So, as it turns out, the effectiveness of a romantic gesture is inversely proportional to the amount of automation that's used, right? So, you know, something that has no automation, like writing poetry or something like that, might be pretty effective, right? But having like your anniversary gifts scheduled to arrive at the exact same time, or FaceTiming on your anniversary, robot stand-ins, the amount of automation decreases the effectiveness of the romantic gesture. And way down there at the bottom is having Alexa say, hey, time for whoopee. it just doesn't work, right? So I wouldn't recommend that one, sorry. But all right, let's get into it. What does my escape game look at? Okay, I'm going to show you what happens as I tie together all of the IoT devices inside of my house. So before I show you this, before I show you the video, I want to give you a warning, or at least this caveat, and that is, if you build an escape room inside of your house, there's no way that you're going to convince friends, family, that you are not a complete and total nerd. So you might as well own it. You might as well live with it, own that thing, and this is what we got. So yes, this is total nerd video here, but I'm going to show you a video, and actually I'm not going to put it on WebEx. I'm going to post this into the chat window here so that you can watch it on your side by clicking YouTube, or clicking the YouTube link. It's going to play YouTube. But let me show you what's going to happen here first. This is a picture of my living room, and here you see the television. Television is turned off, right? So it is not even on at the time. You see some lights here in the coffers in the ceiling, and here you see a thermostat. This thermostat has got Alexa built into it. So I'm going to say, Alexa, start the escape game. And what you're going to see happen is all of the lights in the house are going to turn off. This light is going to turn blue. The front door is going to lock. And the only way out of the house is, well, to solve all of the puzzles that are in there. And then this television is going to turn on, and we are going to see the introduction to the escape game. So two ways you can get this. Oops. I'm going to paste this link into the chat room, or if you're having trouble finding the chat, I wanted to give you an easier to type version of that. So you could go to tinyurl.com, and let's see, can I send to everyone? I could send to organizers. All right, so from this computer, I'll send to organizers. You can go to tinyurl thackersa, and that will, thank you, Carol, I appreciate that. That will get you to that video, or you can watch it for the first one. So I'll sit here quietly for 60 seconds and let you guys go and watch that video. Blake, the link is in the chat, or you can type the one that you see here on your screen. Tiny URLs, the Hackers A for the Hackers Apprentice. Hackers A. All right. Give me some indicator that you guys have been able to watch it. All right, excellent, excellent. It is kind of creepy. It is very creepy. I was going for creepy, so I think, thank you. I think, all right. So all of that automation, everything you saw there could be done with no coding whatsoever. It could have been done just based upon a trigger, right? When that switch change, Alexa will turn on the thing with the Hue bridge. Based upon that switch, I could have set this up through the web page, but I didn't. Instead, what I did is I used Python code to automate the back end because I had a lot more control with it with Python. So let's talk about how you can do some automations with this thing, okay? So there is this thing in Alexa called Python scripts, but what you're gonna find if you try to experiment with this, let me save you some time. Don't get too excited about the Python scripts, right? They're a real disappointment. Within the Python scripts, you can basically only do the same things that you could do with the web interface or with a YAML configuration. You can't even use the word import inside of the Python scripts. So it's rather limited in what you can do. So instead of using the Python scripts, don't focus on that. Instead, what you want to do is you want to go straight to the AppDaemon. The AppDaemon is what doesn't come installed by default with Home Assistant. You have to download that and install it separately. But once you've installed it, you have full control of everything using your standard if-then-else syntax. You can write asynchronous code. You can write procedural code to interface in with those systems. And I'm going to show you some of the code that I've got for my escape game here. And we're going to look at really what it's doing. But there's no restrictions on what you're doing inside of this. You have full control of all the devices with Python code. So this is what my escape game looks like. In order to create an escape game, you have to define a class of an escape game. And in this Python function, or in this escape game function, you have to have an initializer. The whole job of the initializer is to listen for that trigger. So here you can see I'm calling this thing called listen state. And what it says is I've got this first argument here called start game. This is what's going to get called when the following things happen. When the input Boolean called escape game, this is the switch on my web page. When that goes from off to on, it's going to automatically call these start game. And when this program runs, it just sits there and looks for that switch that's on the web page to be triggered. When I use my voice with Alexa to trigger it, then it calls the start game function. Down here inside of start game, it's going to always take in these exact same arguments. But let's look what I do with them here. I record that the game started. I record the start time because you only got 45 minutes to escape the game, so I want to know when you started it. I'm going to turn back off that switch called escape game, so the switch on the web page turns back off. And then I'm going to look at the state of different switches that I've got. So I'm going to look for the state of something called challenge 1 enabled. And if that's set to on, then I call the function called challenge 1. I'm going to look for challenge 2 enabled, and then I'm going to call challenge 2. And what this lets me do is I can have a bunch of different challenges, and I can turn them off and on so I can provide different experiences for people when they come and do different games. So I might give one set of people a set of 3 challenges and another set of people a set of different challenges, right? Or if you come back to my house once and I know that you've already done certain puzzles, I could give you a different set of puzzles, okay? And then the idea is with these different challenges, the challenges will either, well, show you a video, such as you saw. That video will have you go and find things such as a puzzle. The puzzle will then reveal some combination. That combination might unlock a box, such as you see here. I've got some old ammunition boxes that I've got some combination locks on, much like you'd see in traditional escape games. Right, sometimes you'll find keys in the house, and those keys will unlock boxes. Inside those boxes, they have other puzzles. Those puzzles might have you do things that trigger different IoT devices. So I might have you set the light switches in a room to certain combinations, or change the colors of certain light bulbs with Philips hues, or turn on television, set it to a specific channel. Anything that I can monitor within this software is a potential trigger that lets me indicate that you solved the puzzles. So the puzzles themselves have you turn on IoT devices or have you find combinations that unlock boxes that are hidden around the house that moves through the different systems. So here's one of the puzzles that we have in the house. And so when you go and you find this puzzle, it says, excellent job, you show promise. Let me move this out of the way, my camera out of the way so I can see. Excellent job, you show promise, my young apprentice. A hacker must be able to control computers using only their voice. Recreate the pattern at the bottom of this clue, and then things will start to look up for you. The challenge begins when you say, Alexa, turn on hacking beats. Alexa understands lots of commands like turn on downstairs hallway lights, turn on living room center, and things like this. And you see this pattern at the bottom. These pattern at the bottom is telling people to, well, to set lights to a certain condition in the house. Turn some lights off, turn some lights on, turn some lights to the color red. And they have to figure this out through process of elimination using these commands. And well, people who aren't really technology savvy or haven't used a lot of IoT devices, this This tends to be pretty confusing. This is one of the hardest challenges for people to get past, is just figuring out how to use Alexa to turn off and on lights in my home. And then, well, I also have to figure out that where these lights are and where the lights are in my house and which one is associated with each of the different colors to turn on those patterns. So very quickly, my house degrades into people trying to yell at Alexa in order to try and solve this type of technology. This is what the code itself looks like for this puzzle challenge. It says I have this function called light pattern. So when I call this function, I have inside of a little sub function called the lights are right. Lights right will return true when you got all the lights right. I look at the state of the living room center, if it's on. I look at the state of the living room top, it has to be on. The living room right has to be off, so forth and so on. Down here at the bottom, I look at the state of one of the lights and I see, is it red? And if its color is set to red, then this will be true. And so then I use the all function to look to see if each and every one of those variables is true. If they are all true, then this function returns true. If they're not all true, this function returns false. So while the lights are not right, it sits here in this loop and just every 2 seconds goes and checks the conditions of the lights. Once the lights are right, then this function moves past it and I call the service media extractor and I tell it to play media on my Sony television and I tell it to play the next clue. This could be a YouTube video, but in this case, I have it pointing to an internal server, which has the MP4 player, and it just plays the next video clue once you got the light pattern correct. So you can see here that even if you haven't done any Python coding before, it's not horribly complex code in order to write a function like this. And this is checking for all those light patterns. Once they're satisfied, it moves on. Okay. Now, as I said, people who've never done any type of Alexa before, it quickly degrades into, well, people yelling at their laptop or yelling at Alexa and talking to their phones. And yes, so this is a video of a kid just yelling at his Alexa, and it's not doing what he wants. Didn't turn out very well over a GoToMeeting, I realized, but it wasn't that good anyway. So here we go. Here, another challenge. Hackers must be masters of deception. So I tell the people that are playing the game, hey, I need you to create a distraction. I need you to go into my backyard. I turn down all of the camera sensors or the motion sensors in my backyard to very low. And then I tell them that they have to have a dance party, but it has to be a big enough dance party to trigger the motion sensors on my camera. Then I tell Alexa to start playing Billy Joel Pressure everywhere throughout the house. I record the number of alerts that I've currently got on my camera. And then while the number of alerts doesn't change, so while the current count for the alerts is equal to the start count, I'm going to get the count of the next one and I'm just going to sit here in this loop. So every 2 seconds, I'm going to get the updated count. If it hasn't changed, I sit in that loop. When it's done, when the count does change, meaning that they triggered an alarm, then I come down here and I log bad dancing detected, or I announce warning bad dancing detected. Next clue will play in 60 seconds. And I sleep for 60 seconds and then I play a video on my Sony Bravia television. Okay. Another thing I try to do is, if you've done any escape rooms before, you see that there's sometimes this anchor challenge, as I call it, where you'll discover pieces of the main challenge as you go through it. So I have the idea of using these flick Bluetooth buttons. Here I've got one here. So it's just a Bluetooth button. You can get these online for 70 bucks. And the idea is you might solve a puzzle, and inside of an escape room or inside of the ammo box, you might find one of these lights or two of these lights. And if you push the lights, then it would, I had a light that would blink. And the idea was it would be Simon, the world's hardest game of Simon in the world, where you would have to match the pattern of the lights blinking by pushing the right colored buttons. And initially you would only have like the green and the yellow button. And then when the light bulb turns blue, you're like, oh, but we don't have a blue button. And so you would go back and you'd solve more challenges, opening more boxes until you find another, the other blue button, and then you could go back to that Simon challenge and do it. So I had this idea of having this anchor challenge that would be scattered throughout the entire puzzle. And I tried to do this, but I found that it ended up being a very difficult thing to pull off because, well, the range of the Bluetooth buttons is limited because it's Bluetooth. And so you had to be close to the sensor in order to push the buttons, and the users would find the buttons and they wouldn't be near the light bulbs and things like that. Now I've had some ideas and suggestions, or some people have said, well, put a box there that you plug the buttons into so that people know that they have to be there or something like that. But I haven't gotten around to doing that, and the idea has just fallen to the wayside, and I haven't fallen apart. But these buttons are really nice because they can tie together automations and things like that. So today, at the moment, here's one of the Bluetooth buttons. I'm not actually using it for anything useful, but just to show you how they work, I can press this button. Yeah, and right now it's an automated whoopee cushion. So when I push the button, it makes fart noises, because I haven't quite figured out how to integrate this into the challenge. Now, I know what you might be thinking, Mark, how immature of you to have automated fart noises, but here's the thing. The immaturity of flatulence is directly proportional to the amount of, or is also inversely proportional to the amount of automation that is used. So when you introduce Bluetooth to flatulence jokes, then they become significantly more mature than without the presence of automation. So that's the good news about automation. I also have some actual hacking challenges in my escape room, right? So one of the challenges, the video will tell you to go to a web page, and it'll give you the URL. And on the URL, it says, number of ghosts equals 6. And when you go to that web page, you find, well, a JavaScript Pac-Man game that I found an open source Pac-Man. I downloaded it, and I modified the code so that I could control the number of ghosts from the URL. So you go to this website, and you say num ghost equals 6, you hit start, and you play Pac-Man with 6 ghosts. And the clue on the website says you must be an excellent gamer or an amateur hacker to complete this challenge. And of course, since this is an information security podcast, I'm guessing many of you already know what steps you're going to take here. And that is going to be HTML parameter tampering, right? I'm going to control the parameters. I'm going to change those number of ghosts to, well, some other number. As I set it up, the value of each of the points is inversely proportional to the number of ghosts. So if you drop it down to 0, you actually only have to eat a couple of dots before it reveals a combination. So the points become the combination lock, which then unlocks another ammunition box inside of the house. So these are just some ideas for different puzzles that you could have inside of your system. I also say, well, hackers, again, the theme being the hacker's apprentice, I want to have all these hacker-based challenges that are in the escape room. Hackers are experts in OSINT. Can I get a what, Micah Hoffman? All right, hackers are experts in OSINT. And so the clue here is there's a switch in the house that is named after Mark's high school mascot and his wife's record-breaking track time from 1988. So you'd have to do some open source intelligence gathering on my wife, figure out what high school she went to, figure out what her track time was that is still being held as the record for that high school today, and figure out what my high school mascot was. And then once you get those things, you can say, Alexa, turn on mascot time, and that would trigger that switch. Now in this case, right, this switch, this is just a switch. Remember, it's just a YAML configuration. And so when you say that, it sets the trigger off, which then plays the video. So this is a absolutely no coding challenge whatsoever. And that was another one of those combinations. So here's some caveats, things to be aware of as you're working through this. And we're wrapping this up here in just the next couple of minutes. Things to think about. In my house, now I see combinations everywhere. Anywhere there's a switch, anywhere there's a number, that's an opportunity for me to communicate a combination to somebody or collect a combination from somebody. So if I want to communicate 2 digits of a combination lock, I can set the temperature in my house to those 2 digits, right? Okay, maybe I don't want to leave the temperature in my house on 27 degrees, but I can flash it to 27 degrees and then back to 70 degrees. It's not really good for your thermostat, as I have discovered, but you know, you can change these things. I see digits everywhere. My sleep number on my sleep number beds can communicate a digit, or I could have you set my sleep number to a specific digit in order to trigger an IoT event. The television, right? I can figure out what channel things are on, or I could set the channel on the television using that Harmony remote. So if I want to configure a 4-digit number, I could just automatically tune the television to a 4-digit channel, and then set it back to 000, then set it back to that channel again. There's various ways so you can do these things. So now I see combinations everywhere in my house as I look for digits and things like that. Here's some lesson learned, right? So remember, it's still your house, right? This is your house. So these may have been some bad ideas that I've had, right? So having people run around in my backyard to set off my motion detectors is fine if it's a nice day, but if it's muddy in the backyard, then people running outside and doing that and then bringing mud back into the house was less than ideal. Having people do open source intelligence gathering on my wife turned out to be a bad idea when I started inviting SANS instructors over, okay? Let's see. Oh, my wife was not very keen on the puzzle that I made that asked people to lie in our beds in our master bedroom in order to trigger different events within the house. So having people crawl around in your beds, I'm gonna suggest that you get that cleared with your significant other before implementing that challenge. Okay, there's my lesson learned for this. So what do you need to get started, right? We're all stuck at home. What does it take in order to do this? Well, you do need some Python skills if you're going to be building any of these advanced puzzles. But if you just want to do some cool home automation, it doesn't require any coding skills, right? You can just download this software and configure it with web interfaces and get going. But if you want to do some puzzles, you will need some coding skills. If you don't have any coding skills, let me recommend to you that SANS has this course, SEC 573, Automating Information in Security, which I'm the course author for that. We've got it starting in just less than a week now for Orlando. Plus, we're going to be running cybercasts of that class over and over again for the next several weeks. So there'll be plenty of opportunities to do that. You will need Home Assistant. You can get Home Assistant from the URL that you see there, home-assistant.io. It's free open source software. Download that to a Unix system, or you can also do a pip install to install that as a Python module on your system. And then just fire it up. You might be surprised at how much IoT devices you already have inside your house, right? You might be thinking, I don't want to have to go out and buy electronic locks and light bulbs and things like that. If you buy nothing, do you have a wireless access point that your phones connect to and it would know in your home? Do you have a television that is IP enabled that you can turn off and on? So even if you buy nothing, you could do an automation that when you come home, when you walk into your house, when somebody leaves your house, you could then play the social distancing warning videos on your television to let everybody else know that someone has escaped the house at this exact moment, right? So there's all kinds of possibilities. Even if you don't think you have a lot of IoT in your device or in your house right now, download it and give it a scan. It all automatically scans and discover devices that you have on your network. You might be surprised at what you find you have there. And there's lots of opportunities to do this. If you're interested in the code that I have for my escape game, I don't have all of it. I'm not sharing all of it, but I am sharing many of the components that you've seen here, right? There's my Twitter account. If you want to follow me on Twitter, my DMs are also open on Twitter. So if you want to send me a DM, I'll send you a link to the code that's out there, and you can take a look at the code that I've got already for the escape room, or at least components of it, the components of it that I want to share publicly. And that is my presentation for today. So we've got about 6 minutes left. If you have any questions, I'm happy to take them, and I'll try and answer as many of those as I can. If there are no questions, let me just say, I hope each and every one of you are staying safe, taking care of your family, enjoying this time that you have with family, even though it's not in the best of circumstances. I hope each and every one of you are staying safe. And if you have the opportunity to check out 573, as well as many of the other free resources that SANS is offering right now to try and keep people engaged and learning during these difficult times, then I hope you have an opportunity to take advantage of those. So with that, let me take a look at questions, see if there are any, and I'll answer those questions. If not, have a great night. All right, let's see. Wait, did you need a Raspberry Pi to use Home Assistance? Do you need a Raspberry Pi? You can certainly run this thing on a Raspberry Pi. As a matter of fact, they have Docker files for this. They have a Raspberry Pi OS that has Home Assistant in there. So it's a customized Raspberry Pi OS that you can install that has Home Assistant on it. You can absolutely use this. But what I've done is I have it running on a laptop. I have an old laptop that I have Linux on Python, and I just did a pip install to download the entire module and run it there. The reason that I wanted to use a laptop is because of this. I have a speaker on the laptop. One of the things that I do with integration into the Alexa that I've got in my house is at certain times I will actually use Python's text-to-speech functionality, and I will have my laptop speak commands to the Amazon Dot that's sitting on top of the laptop, so I can have it trigger commands through Alexa by the laptop actually speaking to Alexa. So I'm using a laptop for that. Can Home Assistant integrate with Samsung Smart Things? Yes, Smart Hub things and all of the smart homes, many of the other platforms you got out there, Apple's HomeKit and things like that. It does have integrations in with those. If you look through the list of integrations that it's got out there. Yep, good question. Let's see. Flatulence is definitely immature. Okay, all right. I don't disagree, but not when you add Bluetooth. Not when you add Bluetooth. Okay. Any other questions? Okay, I'm not seeing any other questions. So thank you once again, everyone, for joining us tonight. Have a great night. And Carol, is there anything else? Oh, just a reminder, there is the evals for the 92 of you. 92 of you still here. Thank you very much. Just a reminder that there is a link to an eval in the comments. If you wouldn't mind giving SANS some feedback, I'd appreciate it very much. And with that, Carol, is there anything else that we need to do?
You've covered everything. Thanks so much, Mark.
All right, excellent. All right, have a good night, everyone.